Welcome to the Deep Dive, your shortcut to being well-informed, where we really cut through the noise and pull out the important stuff. If you've been paying attention to, well, anything lately, you've seen AI is just absolutely everywhere. It's baked into our daily lives now, right? From phone apps to, I don't know, huge industrial things. It's not sci-fi anymore. It's really here, and it's changing fast. So today, we're going to pull back the curtain on something really fundamental to understanding it all. The complete life cycle of an AI model. We're talking start to finish, its birth, how it's developed, deployed, and even eventually retired. Our mission here is to boil down the key ideas from our sources to help you really grasp how these powerful models get planned, built, rolled out, and, maybe most importantly, how they're kept safe and working right out in the world.
Yeah, and it's a really good time for you to get a handle on this whole journey with AI popping up everywhere. I mean, not just in tech labs, but in, so many industries and even how we interact day to day. Understanding how these models are built and used safely, reliably. It's not just interesting anymore. It's becoming, well, essential knowledge. So we're going to walk through every step, like you said, from that initial idea right through to when it's taken offline, giving you the full picture of what makes AI tick and maybe more critically, what makes it tick well and ethically.
Okay, so let's unpack this journey.
Uh-huh.
Our sources are really clear that we have to start right at the beginning with planning. It sounds a bit, I don't know, dry, planning, but I get the feeling it's anything but simple. Why is this first step, this blueprinting, so incredibly vital? What are the big mistakes people make if they rush this bit?
That's a great point, because planning isn't just paperwork, right? It's where you define the whole purpose, the boundaries of your AI. The biggest pitfall, jumping straight into coding without really nailing down what exactly is this thing supposed to solve? Who's it for? What should it actually do? Our sources really hammer this home. If you skimp on this, you can end up with a technically amazing model that, well, solves the wrong problem, or one that just fails completely when it hits the real world. Think about building a bridge, but you haven't figured out where the riverbanks are or what needs to cross it. You might build something impressive, but
It doesn't actually connect anything useful. Yeah, that makes total sense. And the sources give this great, really relatable example, designing an AI model to help people cook, create recipes from scratch. Sounds fun, right? But it immediately shows you need precision. You definitely don't want it suggesting glue instead of cheese in your lasagna.
exactly. That lasagna example, it really drives home why good planning and especially good data is so critical. It's non-negotiable. Once you know what the model needs to do, help with recipes, the very next thing in planning is figuring out your data. And it's not just about getting lots of data. It's about getting the right kind, relevant data. Data with integrity. For that recipe helper, it means carefully gathering, conversations about cooking, recipes from trusted places, solid techniques, all specifically tailored to that job.
So not just grabbing any old cooking website data. It has to be the right stuff. I guess right also means sourced responsibly.
Oh, absolutely. The sources stress this. Using diverse data isn't just a nice to have, it's your main defense against accidentally building in biases. Biases that could leave out whole groups of users or just lead to weird, unhelpful suggestions. If your recipe data only comes from, say, Western Europe, your model's going to struggle with Asian or African cuisines, right? And that idea of traceability, knowing exactly where every piece of data came from, that's like your insurance policy. Imagine trying to fix a problem later, an ethical issue or an accuracy bug, without knowing the source of the bad data. It's almost impossible.
Okay, so traceability is key. And before you even use the data.
Right. Before using it, it gets a serious cleanup, rigorous cleansing. This means stripping out any PII, personally identifiable information, anything that could identify a person, plus getting rid of duplicates, filling in missing bits where possible, making sure the format is consistent. You want it pristine. And a really big part of this is proactively checking for bias in the data itself. If the data you collected is, say, skewed heavily towards one demographic, that could lead to unfair results. So one technique is to actually generate synthetic data, artificial data, to fill the gaps and create a better balance.
Right, create balance where it didn't exist naturally. Okay,
Yes.
so careful planning is done. The data is sorted, clean, balanced, ready to go. Now we get to the exciting bit, building the actual model. I'm guessing this isn't like picking one tool off a shelf. The sources talk about a huge variety of ways to build these things.
You hit it exactly. This is where the blueprint turns into something real. And the choices here are, well, fundamental. There's a whole toolkit out there, different algorithms, methods, architectures. It's vast. For our recipe model example, the conversational one, the sources suggest starting with something called a transformer architecture.
Transformers, yeah, that term pops up a lot. But what makes them the right choice for something like recipes? What's the magic there?
It's a good question. Transformers were, well, a bit of a revolution in AI. They're really good at understanding context. Instead of just looking at words one by one, they process whole chunks of text together. This lets them grasp, the relationships between ingredients and steps in a recipe. Really important for a natural conversation. Like the sources say, they're just great at processing and generating text. But then you can get even fancier. To make it work better and maybe use less computing power, less energy, you can use something called a mixture of experts architecture.
Mixture of experts. Okay, that sounds clever. How does that work? How does it help efficiency?
It's pretty neat, actually. Instead of one giant model trying to know everything about cooking, you have several smaller, specialized expert models. Think of it like having one expert just for baking substitutions, another for grilling techniques, maybe another for vegan options. When your question comes in, how do I make this gluten-free? The system routes it to the best expert for that specific job. This can make things faster and definitely cuts down on the computational costs because you're not firing up the whole massive thing for every single query. Now, obviously, there are tons of other ways to build models, but these give you a solid starting point for something complex like our recipe AI.
Okay, so we've got this sophisticated model built now, planned meticulously, great data, smart architecture. But the big question is, how do we know it's actually any good? Like, really good? Accurate, fair, doing what we wanted. This sounds like where stage 3 comes in. Evaluation and validation. What kind of checks are we talking about? It sounds intense.
It really is. This is where serious oversight happens. Our sources point to the crucial role of an AI governance review board. And this board isn't just ticking boxes, it's there to make sure the model follows the rules, like the EU AI Act, for example. Those rules are designed to ensure AI is, safe, transparent, fair. For the actual testing, we go way beyond just, is it accurate overall? We have to check for fairness specifically. That means measuring how well it performs for different demographic groups. Does it work as well for everyone? We also look for diversity in what the model puts out. For the recipe model, does it suggest a wide range of cuisines or just the same few over and over based on its training?
So it's not just about being right most of the time. It has to be right and fair for everybody.
Exactly right. And this also means really pushing the boundaries with testing, brainstorming edge cases, those weird, uncommon situations. What happens then? For the recipe AI, maybe in edge cases, give me a dessert using only things from a gas station, and I'm allergic to nuts, dairy, and gluten. You test those tough ones. And if testing reveals problems, disparities, then you fix them. That might mean tweaking the algorithm or maybe adding more data, perhaps even more synthetic data, to address the specific weak spots you found. It's a cycle. Test, find, fix, test again.
Wow, okay. So the model really has gone through the ringer by this point. Planned, built, evaluated, validated inside and out. Passed all the tests. It's accurate, it's fair. So now it's ready for the spotlight. Deployment. Getting it out of the lab and into the real world, into users' hands. I imagine that launching it safely and reliably is a whole other mountain to climb.
It definitely is. Deploying isn't just flipping a switch. The sources are clear. The process needs to be repeatable, automated, and super secure. Think of it more like launching a spaceship than just, uploading a file. You need precision. Usually this involves using a cloud platform, setting up all the necessary bit storage, computing power, networking, and then containerizing the model.
Containerizing, right? That term comes up a lot in tech. For listeners who aren't deep in the weeds, what does that actually mean here?
Yeah, good question. Think of a container like a standardized shipping box. You put the model inside it, along with everything it needs to run all the code, the libraries, the settings, everything. This means that wherever you ship that container, a different server, another cloud environment, it's guaranteed to run exactly the same way. It solves that old, well, it worked on my machine problem. But here's the really crucial part our sources emphasize. Deployment isn't the end. Not at all. It's actually the start of, continuous responsibility. Once it's live, you need ongoing care. That means constant monitoring, careful version control so you know exactly what version is running and what changed, and, critically, regular retraining. These are vital to keep it healthy and trustworthy.
Okay, so definitely not set it and forget it. Sounds like you're constantly watching it. What are you watching for?
Precisely. One of the biggest things to watch for is something called drift. Drift is sneaky. It's when the model slowly stops performing as well as it did initially, maybe because the real world changes. Think about it. User behavior changes, new trends emerge. The data the model sees in the real world starts to look different from the data it was trained on. If you don't watch for drift, the model can become inaccurate or unfair or just plain irrelevant, and you might not notice until it causes real problems. It's like a subtle decay. So routinely monitoring for drift is absolutely essential for fairness and reliability over time.
And besides drift, what else are you monitoring?
Yeah, you're also watching the basic performance stats. Throughput, can it handle the number of users? Latency, how fast does it respond? Nobody likes waiting. And error rates, how often is it making mistakes, like recommending glue? You need to track all of this to make sure it's performing well, reliably, quickly for everyone. And to deal with drift and keep performance high, you need a solid retraining plan. That means scheduling periodic retraining with new data, often setting up automated systems that trigger alerts or retraining pipelines when performance starts to dip.
Okay, that makes sense. Continuous improvement, basically. And then finally, like everything, AI models eventually reach the end of the road. Stage 5, retirement. What happens then? Do you just delete?
Not usually, no. It's a bit more structured. When a model isn't needed anymore, maybe a better one replaced it. Or the task it did isn't relevant, it doesn't just vanish, it typically gets archived. Archiving means it's stored safely away. This is important for records, maybe for audits later on, or even potentially for reference if you need to understand something about how it worked years down the line. It's a responsible way to end the life cycle, ensuring you have that history if needed.
And there we have it. We've walked through the whole thing, haven't we? The entire AI model life cycle, step by step. From that initial spark of an idea, the planning, the data, the build, the intense testing, the launch, the constant watching, all the way to its final archive. It really shows how much careful thought and effort goes into making AI that, actually helps people and does it reliably and responsibly.
Exactly. And that whole process, all those steps, focusing on planning, on data quality, on testing, on monitoring, it's all designed to prevent problems like bias and drift. It's about building trust and transparency into these systems that, let's face it, are having a bigger and bigger impact on all our lives, which actually brings up a really interesting question for you, the listener. Now that you've sort of journeyed through the life of an AI model with us, from its birth to its retirement, what aspects of AI are you maybe most curious about now? What else do you want to understand? Or perhaps, how does knowing all this change how you might think about or interact with the AI tools you use every day? Something to maybe chew on.